Now it's time for NLP. So continuous random variables and their probability functions used in NLP, natural language processing. So in natural language processing, there are many examples of continuous random variables and their corresponding probability functions. Here are few examples of it. The first one is word embeddings. Word embeddings. So word embeddings are a way of representing words as high dimensional vectors. The distribution of these vectors can be seen as a continuous random variable with a probability density function that depends on the choice of embedding algorithm and the training corpus. The probability function might be a Gaussian distribution centered around the mean of the embeddings or a mixture of Gaussians. And second one that we have here is language models. Language models are used to estimate the probability of a sequence of words. This involves computing the probability of each word given the previous words in the sequence. The distribution of the probability scores can be seen as a continuous random variable with a probability density function that depends that depends on the model architecture and the training data. The probability function might be a log normal distribution or a mixture of exponential distributions. And the next one that we have here is sentence embeddings. Sentence embeddings, similar to word embeddings, sentence embeddings are a way of representing sentences as high dimensional vectors. The distribution of these vectors can be seen as a continuous random variable with a probability density function that depends on the choice of embedding algorithm and the training corpus. The probability function might be a multivariate Gaussian distribution centered around the mean of the embeddings or a mixture of Gaussians. So these are these are just a few examples of the many continuous random variables and their probability functions used in NLP.